The third video in the Set About series looks at what's called the method of differences. It involved functions like 1 over r minus 1 over r plus 1, and it's nice in that most of the terms actually cancel out. It's easiest to show through an example how that happens. So this example starts by asking us to show that 1 over r minus 1 over r plus 1 is equal to 1 over r times r plus 1, and then hence, so using that result to find the sum of the series 1 over 1 times 2 plus 1 over 2 times 3 all the way up to 1 over 30 times 31. So the solution to the first part is just using subtraction of fractions, so just our normal method of getting common denominators, so timesing this one, numerator and denominator by r plus 1, and multiplying numerator and denominator of the second one by r to get a common denominator of r times r plus 1. So that gives this result. So we get r plus 1 all over r times r plus 1 minus r time all over r times r plus 1. Putting the fractions together, we get this result where the r's cancel out, leaving us with the 1 over r times r plus 1, which is what we want. Now, it's to link this result with what's happening in this series. So you can see that this series is a number times one more than itself, which is what this is actually talking about here in the denominators. So 1 over 1 times 2 plus 1 over 2 times 3 all the way up to 1 over 30 times 31 can be written using sigma notation of 1 over r times r plus 1, where r goes from 1 up to 30. Now, because of part 1, we can use the result that 1 over r times r plus 1 can be written as 1 over r minus 1 over r plus 1. So that sigma notation for the series we've got here, we can adapt and write it as 1 over r minus 1 over r plus 1. And the reason we do that is to get the terms starting to cancel out. So what we do now is we start substituting in to our function and build up our series. So putting 1 in, we get 1 over 1 minus 1 over 1 plus 1, so 1 over 2. So that's this row here, 1 over 1 minus 1 over 2. If we put r is 2 in, we get 1 over 2 minus 1 over 3, which is that row there. If we put r is 3 in, we get 1 over 3 minus 1 over 4, which is that row there. I've actually lined them up so the denominators match in columns. At the other end, when we get to substituting in 29, we get 1 over 29 minus 1 over 30, which is that row. And then lastly, we get 1 over 30 minus 1 over 31, which is that row. And if you look, because this term is negative and the next term is positive, we get minus a half plus a half, which is 0, and then minus a third plus a third, which is 0, and then minus a quarter, and then we'd have plus a quarter from when r is 4. And then at the other end, we've got minus 30 plus 1 over 30, which cancel out, and then the minus 1 over 31. So everything in this block all cancel out. They all pair up, one negative, one positive, and cancel out. So we're just left with 1 from the start and minus 1 over 31 from the end. So we can say that the sum of r from 1 to 30 of 1 over r minus 1 over r plus 1 is just 1 take away 1 over 31, which is 30 over 31. And we can generalise this method for a series of any length. We can look up to 100, we could look up to n. If we had up to n, then we would just have a sum of the series in terms of n at the end.